Okay, so we're starting off here. You had mentioned a zero-dimensional cube.
Yeah,
So we decided to include that. And then we have the 1 and the 2 here. Okay. So I guess first I should ask you, what do you think the definition of a cube is, actually, now that we're looking at these?
Well, it's like a platonic solid that has squares for sides.
Okay, yeah, that's a three-dimensional cube.
And then
How about a general
so
cube?
a platonic solid that has maybe platonic solid that has sides of 1 dimension lower
Okay,
of that platonic solid.
interesting.
But that could work for all platonic solids. So I guess you could define a 2-dimensional version of it as a square,
Okay.
and then you could go from there, I guess. And then you would create the cube, and then create the hypercube from that.
Okay, interesting. So tell me how you would use your definition starting from dimension 0 here.
Well, starting from dimension 0, it doesn't particularly define because there's not really a dimension below that.
Okay.
But from dimension 1, we can just, the line is just made up of infinitely many points
Uh-huh.
that are just stretched out. And then we first create the square by including 4 of those. And then we create the cube.
Here, we have the cube off to the side here, so
We use,
let me take these away. Yeah, so what do we do with the square to make a cube?
so we use 6 of those to create the cube. We use 6 squares.
Uh-huh.
And then to create the hypercube, let's see, so I think there's 8
Okay.
squares.
8 cubes.
8 cubes, yes.
Yeah. Well, that's an interesting process. Okay, so let's go back and talk about what we're seeing here. Can we see the first 3 shapes, or the first 2 shapes here with our shapes?
Yeah, because a plane is 2-dimensional, so we're not really projecting onto the, so you can just easily see it.
Okay, yeah, so that's not too difficult. All right, but now let's look at our. We actually made the hexagon shape. Everything in view, okay?
Yep.
We made this, and how in the world are we gonna? I mean, it's not gonna be the same size, but it's fine. How in the world are we gonna see that hexagon shape in here?
So maybe we have to line up
Okay, I'll look through there. I'll tilt that down.
these
for-
2 vertices, something like this would work.
No, nice.
So, yeah, so we're lining up 2 of the vertices, so that's why we only have 7. And then the other 6 make up the outer portion of the hexagon.
Okay, cool. Cool. Wow, that's really great. All right, and now I guess we're gonna try to see here if we can see the 4-dimensional shadow. I don't know how easy or difficult this one's gonna be, but we can give it a try. And then we're gonna talk in the next video a little bit more about 4-dimensional cubes.
Well, so it looks like we have 16 vertices, so none of them can line up.
Okay.
So that's gonna make it a little tricky. So we have, the outer shape is an octahedron.
An octagon.
Octagon. Something like this wouldn't really
Oh wait.
help us.
Yeah, but that's nonetheless pretty neat. Can you move that to the center so it's in the picture? That's a pretty neat projection. Huh, so how many did that have along the outside?
Only 6 again.
And how many on the inside?
6.
And then the very inside has 1.
1.
Wow, I didn't know about that projection, did you?
No?
That's pretty cool. Alright. But we need 8 and 8. So there we got 6, 6, and 1.
Well, it looks like if we start with this and we try to move some of the vertices on the outside to create an octahedron, the bottom ones are going to move inside. So it looks we might never get our octagon shape.
That's a shame. Okay, well, we are going to talk one more video about these four-dimensional cubes.
Okay.